In this video, we're looking at more advanced problems involving raising a power to a power. Before we get into that, here's a quick question for you. Are these equivalent? Yes or no? Pause the video and have a quick think. The correct answer is no, they are not equivalent. Let's think about 4x all raised to the power of 3 for a moment. So that's 4x in brackets all raised to the power of 3. That is actually equivalent to 4x multiplied by 4x multiplied by 4x. That's what we get when we raise something to the power of 3. We multiply it by itself and by itself again. And this gives us 64x cubed. And clearly, this is not the same as 4x cubed. So, what's the reason for the difference? Well, in the case of 4x cubed, what we've actually got is 4 multiplied by x cubed. Only the x is being cubed. Only the x is being raised to that power of 3. If you compare it to this expression, the 4 is also being raised to the power of 3. It's also being cubed. And that's where the 64 comes from. Let's get into the examples. We need to fill in the missing values. Question A is what we've just been talking about. We've seen that 4x all raised to the power of 3, or 4x cubed, is simply 64x cubed. What we had to do was raise the 4 to the power of 3 and the x to the power of 3. And in general, when you have a product raised to a power, what you have to do is raise each part of that product to the power. Let's look at question B. We've got xy all raised to the power of 3. Using this idea up here, we can see that we need to raise the x to the power of 3 and the y to the power of 3. So we get x cubed, y cubed. That's a quick way of getting the answer. But if you ever forget, or if you want to try and understand what's really happening, we can use a slower method that involves going back to things you already understand. We know that xy all raised to the power of 3 is simply going to be xy multiplied by xy multiplied by xy. Now, there are invisible multiplication signs between the x and the y as well. So what we've really got is x times y times x times y times x times y. And all together in there you can see we've got an x times an x times an x. That's where we get the x cubed from. And we'll also have that multiplied by a y times a y times a y, which is where the y cubed comes from. We just need to be really careful. So let's just compare that for a moment with something that looks like this. It's important to note that this is not equivalent. It's not the same thing. Now, I won't go into more detail on this for now. That's a topic for another video, but just be really careful when trying to apply this rule. And like I said, if you're ever not sure about one of these, use a slow method. Go back to what you already understand about indices and write things out in full. Okay, let's go on to question C. Here we've got xy squared all cubed. Now, this is exactly the same as before, except the y is now a y squared. But the principle is still the same. We are cubing both parts of this product. We need to cube the x and we need to cube the y squared. So x cubed is just x cubed, and y squared cubed is y to the power of 6. We know we can raise a power to a power by multiplying those indices together. So 2 times 3 gives us the 6. Now let's just see this in a slow way just to help you understand. Xy squared, the thing in brackets there, is x times y, and we are raising that to the power of 3. So I've got that multiplied by x times y multiplied by x times y. And hopefully you can see that altogether I'm going to get an x multiplied by an x multiplied by an x. That's where the x cubed comes from. And then I've got that multiplied by y times y times y times y times y times y, which is where we get y to the power of 6. Okay, let's move on. Pause the video and have a go at question D for yourself. Here's the answer. We have x squared multiplied by y all raised to the power of 3. So we need to raise x squared to the power of 3 and also raise y to the power of 3. X squared raised to the power of 3 is x to the power of 6, and y raised to the power of 3 is just y to the power of 3. Moving on to question E. It's very similar to D, except this index has changed from a 3 to a negative 3. But apart from that, the process is exactly the same. Can you see what the answer is going to be? Hopefully you've spotted that it is x to the negative 6, y to the negative 3. So x squared to the negative 3 is simply x to the power of 2 times negative 3. And y to the power of negative 3 is simply y to the power of negative 3. Some students like to put in the invisible 1 here. Remember, y is the same as y to the power of 1. And then they can think of these questions as simply multiplying these indices. 2 times negative 3 gives us the negative 6, and 1 times negative 3 gives us the negative 3. If you found that helpful, you might like to pause the video and have a look at all the previous examples where I've now put in all those invisible 1s. Okay, I hope some of you found that helpful. I'm now going to delete those ones just to make the page look a bit cleaner. And we can now move on to example F. Here we've got negative 3 multiplied by x to the half multiplied by y cubed, all raised to the power of 4. So each part of that product needs to be raised to the power of 4. Let's start with the negative 3. Negative 3 to the power of 4 is 81. Next, let's look at raising x to the half to the power of 4. That's simply x to the power of 2. A half multiplied by 4 is 2. And finally, we've got y cubed raised to the power of 4, which is y to the power of 12. 3 times 4 is 12. So altogether, negative 3x to the power of a half, y cubed, all raised to the power of 4, is 81x squared y to the power of 12.